Hello, today we'll understand how to write complete ionic and net ionic equations. So let us first start with a single displacement reaction. So the reaction taking place is between calcium and silver nitrate. Here calcium is a solid and silver nitrate is aqueous. So because calcium is more reactive than silver, we can check that out from the reactivity series. So what this is going to do is replace or displace silver from silver nitrate. So silver will come out alone in the form of a solid and calcium will combine with nitrate to form calcium nitrate. So calcium nitrate will be written as CaNO3 whole twice, and this is going to be aqueous because this is soluble in water. Now we'll balance out this chemical equation. So nitrates over here are 2. So we are going to put a 2 right here in the front, but this makes silver also 2 atoms. So we'll put a 2 here to balance out the silver on the right. Now this is a molecular equation or just a normal equation. Now we'll write the complete ionic equation. So keep in mind anything which is aqueous in a normal equation, it will break down into its respective ions in the complete ionic equation. So because calcium is a solid, we'll write it down as such, and silver nitrate is soluble in water, it's aqueous. So we'll break it down into its respective ions. So we'll have 2Ag with a 1 positive charge, aqueous, plus 2NO3 with a 1 negative charge, again aqueous. Now this gives us silver is in solid state, so we won't break it down. We'll just write it down silver as solid, and then plus because calcium nitrate is aqueous, so let us break it down again. So we have Ca with a 2 positive, which is aqueous, plus nitrate ions, so 2NO3 with a 1 negative, again aqueous. So this is our complete ionic equation. Now we can see that the nitrate ions over here in the complete ionic equation, they are unchanged. So they are exactly the same on the right and the left side of the equation. So the nitrate ions are called as spectator ions. So what we need to do is, now we'll cancel out our spectator ions on both the sides of it, and then whatever we are left with, we are going to write it down. So we have Ca solid plus 2Ag 1 positive aqueous. It gives us 2Ag solid plus Ca 2 positive aqueous. And after cancelling out the spectator ions, what we got is called as a net ionic equation. Let us now take another reaction, which is a specific type of a double displacement reaction, a neutralization reaction. So we are taking an acid, H2SO4, aqueous, and this is reacting with NaOH base, which is again aqueous. We know that in a double displacement reaction, the sodium will go with sulfate and the H will go with OH. So we have Na2SO4, which is aqueous because it is soluble in water, and H and OH together, it will produce H2O, and H2O is a liquid. Now we'll balance this out. So sodium, we have 2 on the right, we'll make it 2 on the left, and now hydrogens, we have 2 over here and 2 over here. So a total of 4. So we made 4 hydrogens here, and now the chemical equation is balanced. To write down the complete ionic equation, anything aqueous, we are again going to break it down. So we have 2H positive plus SO4 with a 2 negative plus 2Na positive plus 2OH with a 1 negative, and this gives us 2Na with a 1 positive plus SO4 with a 2 negative and plus 2H2O written as such because this is a liquid, so it is not aqueous for us to break it down. Now we'll cancel out the spectator ions. So the spectator ions are Na2 positive ions and SO4 2 negative ions. So we are going to cancel them out. And now we'll write our net ionic equation. So our net ionic equation is 2H positive aqueous plus 2OH with a 1 negative aqueous, and this gives us 2H2O, which is a liquid. I hope you understood the process. See you in the next one. Bye-bye.